Hello. Okay, this time we're going to look into adding a health system to our game, and I also want to fix what I think the biggest problem we have is. But before we get to that, I wanted to draw your attention to a thing I've just made. I thought it'd be good to have a reference sheet for just very common things that is easy to forget in terms of like how do you, when you're declaring a variable, you say the type, and then you say the name you want to give it, and then equals, and then what you want to store. And a reminder of what all those types of variables are. I never thought of this before until I came to write this, but the ones that start with lowercase are kind of basic things, quite simple things, and the ones that start with a title case are more fancy. I would be lying if I said it made perfect sense. That was a thing that tripped me up for ages, was which ones start with a capital and which ones don't. Because game object, for example, if it's a type, it starts with a capital, but if you want to refer to the game object you're using, it's a lowercase. So there's all kinds of gotchas like that. In fact, I should add that here because that's not in there yet. That particular distinction. What a prefab is and what to watch out for there, how to write an if statement, all these weird little symbols for checking things or doing things. In fact, all of these involve equals with some combination of other symbols. So just a reminder of what those are. And in particular, this one's important. Variable equals something, makes variable equal to something. Variable equals something, checks whether it currently is. Common keywords, and then a section for pitfalls. I'm just going to read these because it's good to keep these in mind. When you're setting a float variable to anything with a decimal in it, if you're writing a decimal point at any point in that number, you have to put an F on the end. It's dumb that you have to do that because you already said it's a float variable. Should be implied. But the F is to remind the system that you do mean a float. Like, oh no, I really do mean a float. I know a decimal can be interpreted different ways, but this time I mean a float. All right, fine. If you change a variable on something while the game is running, that change will be lost when you stop playing the game. The exception to that is if you edit a prefab while the game is running, that change will stick around, but I'm saying don't rely on that because it's very easy to forget or not realize that you're editing a prefab when you're editing an instance or vice versa. So in general, just only edit things at runtime if you are trying to edit a specific instance in the scene and you're okay with those changes being lost. And then if you're editing something in the game world, you're not changing the prefab. If you want your changes to apply to other copies of the thing, you have to edit the prefab itself. I don't know why I didn't think of this when I was explaining prefabs in the first place, but the analogy I came up with here is a prefab is like a blueprint for an object. It is not the object. It's not a real object that you could, push around and do things to. You can't. It doesn't exist in your scene. It's a blueprint for it. So anytime you're interacting with an object in the game world, you're not doing anything to the prefab. You're doing something to the instance, which is a copy of a prefab. So. In our game, let me just play it and just remind us where we were. The player can now shoot at the cursor, which is great. And the rate of fire is a thing we can now change as a variable, which is also nice. It's not just dependent on how fast the updates are going. And our bullets shrink out of existence. I haven't kept the change where I was making enemies replicate themselves. If you made that change with me last time, I wasn't sure when I was doing it whether it was a mess around or whether it's part of the lesson. For now, we're going to leave it out because obviously it can crash the game pretty fast. So the thing that is bothering me, I want to add a new enemy type, and the problem I'm going to hit when I do that is that every enemy, we had to manually give them a reference to the player. All of them had to be told, this is the player, this is you, this is the player, Tim, this is the player, James, this is the player, Anna, this is the player. And that's ridiculous. We shouldn't be doing that. I said at the time this is not a great way to have for the enemies to know where the player is. They could be doing some detection logic. They should be casting out rays to find the player and expanding spheres to detect them and stuff. Eventually, maybe we want to do that if detection matters. But detection doesn't matter. In our game right now, we just want the enemies to know where you are. There should be just some fixed place that everyone can see that just tells them, that gives them a reference to the player. And so do you remember when I've been talking about things like, let's see, in player behavior, when we wanted, do we have any references to this left? When we did like input get button, I described that as calling the input hotline and saying, hey, I want some information about whether a button was pressed, and the button is this. And for timing stuff, for rates of change, we called up the time hotline and we said, hey, tell me how many seconds it was since the last update. Well, today we're going to create our own hotline. So this will be our first code that isn't attached to any particular game object. So rather than making it in the scene, we're going to click down here in the project window and say create C# script. And the name I'm going to give it is just references, because this is just going to be a place that we store references to things, things that are in the scene, because that's the problem we have. We can't. All our enemies are getting their data from a prefab, a single prefab, which is in our project folder. We can edit this. The field under enemy for the player, I can't set that to something that's in the scene because prefabs have to sort of have to only refer to other prefabs. It's a blueprint. So if you imagine like a blueprint for a building saying, oh, if you want a reference to the player, it's that guy over there standing to your 3 degrees to your left or something. Reading the blueprint, you're like, whoa, hang on, this is a blueprint. This has to work in all situations. Like, I don't know what you're talking about. I don't know if that really helps edify that, but the important part is a prefab can't refer to a thing in the scene. That's our problem. And we want all our enemies that we ever create to always know where the player is. And so we don't want to have to set that manually. So we've created a file called references here, and we double click it to open it in Visual Studio. And Unity has assumed we want to make a mono behavior. So this is the same stuff we see every time we create a new script when we create it on something. Mono behavior is a behavior. It's a script that gets attached to a game object and tells it how to behave. It's also a component, which is, rigid bodies are too, transform is too. The thing we're going to write now isn't a component. It's not a behavior. It's nothing like that. So we're just going to delete the word mono behavior and the colon that goes there. That colon, by the way, just you don't really need to know this, but when there's a colon like that, it's telling you that references is a type of a mono behavior. It's sort of like a subset of it. It's a special case of a mono behavior. But ours isn't, so we're going to delete that. Public class references, we're going to delete everything in between these two brackets. Start and update, those are all things that apply if you're in our world. If start is what happens when you're created in our world. Update is what happens every tick in our world. But references isn't going to be in our world. It's never going to enter our world. It exists outside of those, so it's never going to do anything like that. And in fact, the key thing we want here is we want everyone to be able to access this thing, and normally you can't. And so between the words public and class, we're going to write the word static. Static means it can be accessed from anywhere. And the reason that word has that meaning in this context is that the reason you can't normally access everything from everywhere is that Unity doesn't want you to write a line of code where the thing it's referring to might not exist, or it might be ambiguous what you mean. When you say enemy, which enemy do you mean? Which one are you talking about? Right now we only have one player. Unity doesn't know that. Like, we could have hundreds of players. So we can't just write player because players are not a static thing. The number of players can change. There might not be a player in the scene. If we're just doing a menu, why would the player be there? Maybe they're not. And when you say static like this, you're saying this will always be here. This is automatically always and forever. It's timeless. It's Stonehenge. It's not going anywhere. And so that means we're free to refer to it from anywhere at any time with very easily. And then all we're going to do in here is we're going to write a public variable. In fact, let's do it like this. Public player behavior, the player. So we've declared a variable, but actually we need to write the word static in here as well. Public static is what our class is, and that's also what this variable is going to be. So static again just means I'm telling you this variable is going to be here all the time, forever. Everyone can do it. That's my oven getting up to temperature. And with that, we're done. This is our whole class. This is all it doesn't do anything. I was going to say this is all it does. It doesn't even do this. It doesn't do anything. All it is just a place to store one piece of information. Later, the reason I've called it references and not player reference is because we will use this later probably to do things like keep track of all the enemies in the scene. You can have a list of all the enemies. That'll be useful to loop through it and see like who's the closest enemy to me and that kind of thing. Or if I want to delete all the enemies, we could do it that way. It's just going to be very useful to have a place to store references. And so it doesn't have a reference yet, and it won't, before the game starts. But when the game starts, we want our player to call up this hotline and say, oh, you know you have a place for a player reference? That's me, I'm the player. So we're going to call the references hotline. References dot the player equals this. I'm not, because I just realized I've done this differently to how I planned to do it, and I'm trying to decide whether it's worth changing it to how I was planning to do it or not. Let's see. Let's roll with it. Let's stick with this. So I've made this a reference to the player behavior in particular. It could have been a reference to a game object. I could have written game object there. In fact, yeah, sorry, I am going to do that. I'm going to write the game object there. Sometimes it's more convenient to store the player behavior part of the player, but if you write game object, you're storing the whole thing, and that is, we will do it that way because, and then instead of writing the player equals this, we're going to write game object. That word this, we haven't used that before, so don't worry about it yet because we don't need it yet. The player is going to be a reference to a game object, which is the whole player. You know, it has its rigid body on it, it has its player behavior, it has its transform, all that stuff. Yeah, forget the player behavior part. That is how I'd probably do it in the game I'm working on, for various reasons that we don't need to get into yet. So yeah, when the player starts, it's going to call up references hotline and say, hey, you have a reference to the player. That's a type of game object, apparently. That's me. It's my game object, because what we're writing here is the player behavior, and the player behavior has a reference to the object it's on, and it says, okay, this thing I'm attached to right now, that's the player game object. And now, enemy behavior, which is where, which has this problematic reference to public game object. I'm just going to switch back to Unity just to sort of, so I'm not switching between abstract windows of code all the time. Here's our enemy, and here's the enemy behavior. It's got this reference to the player that we have to set because it's the slot that we have to fill in. I'm just going to delete that. And when I do this a lot where I know that is a thing that's referenced somewhere else. Rather than try and remove all the references to it and then delete the declaration, if you just delete the place it's declared, Visual Studio will highlight the places that now are broken. Like, hey, you said player down here? I don't know what you mean by player anymore because you no longer told me about that. So we're going to replace that word player with references hotline dot the player, and that's it. And now we save that, and that will have, all our enemies have a reference to the player that we don't need to set, and if I play the game it should just still work much as it did before. Yep, they're all seeking me correctly. And now there's actually a bonus, which is if I go to the scene view and I drag an enemy into there, I can drag loads of enemies into here and they all chase me. I don't know if you ever encountered this before with our previous code, but if you added any enemies that way, if you drag them into the scene, they wouldn't chase you. And in fact, there was a time when I spawned loads and loads of enemies, and they just kind of lay there, and the game ran really slowly. And that's because when you're just copying it from the prefab doesn't have reference to the player normally, and so they were not able to chase the player because they didn't know who the player was, and also that's why I was seeing slowdown. You remember I was surprised because I thought capture colliders were really efficient, and yet I was getting a lot of slowdown really quickly. It wasn't the physics, it was the fact that they had this reference that every time they checked it, they were getting an error, and that is slow in Unity. If there's an error coming up all the time, that's going to slow the game down. It's one of many reasons you don't want to have errors going on all the time in your game. So, to show you why what we just did is good, let's create a new enemy type. Let's, over here, I'm going to right click and say 3D object, and we'll make this one a cube, I think. Yeah. And I'm just going to reset its transform up here. That's just the same as typing 000 in here. And sorry, I should be in scene view so we can see these arrows. Drag it around a bit, and I think this one should actually be big. Let's make it bigger, maybe even 3 by 3 by 3. Big hulking enemy. And is 2 the right height there? Yeah, that looks right, doesn't it? It's just touching the ground. And what does this need to be an enemy? Well, it needs an enemy behavior. So if we type add component and then find our enemy behavior, we can add that there. All these little guys, they are speed 8. The big guy let's make him speed 3. So this is starting to get into like the sort of powerful thing in Unity. You know, we defined what an enemy is. We can just create any old object, put an enemy behavior on it, and it will work as an enemy, he says before he tests it. Aha, okay. This is a useful and very intentional problem that it's kind of fun to like try and get them trapped behind the big enemy. Anyway, it's not moving for this reason that it tells me down the bottom, which is the thing doesn't have a rigid body. If I bring up the console here, you'll see it here. And oh yeah, this is a good thing to know actually. When there's an error like that, I just double clicked it. It opened up Visual Studio. I'll do it again. And it highlighted the line that's the problem. This thing about, oh, we're assuming we have a rigid body. I'll do this to it. That line of code is actually fine. That's not the problem. The problem is I should have added one here. So this is on our big cube enemy, and I've just add component rigid body. And let's name this guy actually. Cube enemy, or maybe big enemy. I mean, go wild with your imagination. And I'm just going to test that now. So now, yeah, they move towards me and they tumble. And the other ones kind of interfere with them and kind of ride them along. That is kind of fun. That isn't what I want. Oh wow, I can go under it and trip him up. Oh man, this is too cool. I don't want this behavior though. I don't want to find out that it's great. That might be great. You might want to keep it, but we're not going to keep it because the reason I wanted to add a new enemy type is that like tumbling lozenge enemies is kind of a weird niche thing. And the point of this tutorial is not for you to make this one specific game, it's for you to learn how to make, you know, games in general. So it's actually better if our game is a bit more generic. So I want this enemy to be more generic. I want them to be, I don't want them to tumble around like a physics object. I want them to move a bit more intentionally, like they're a big tank or something. And so we are going to give them, do you remember on the player, we didn't want the player to tumble around, and so on their rigid body, we locked their position on the y-axis so they can't go up or down, and then we locked their rotation on both of the other axes. So they can still rotate around the vertical axis, so like if they have a skewer through their head, they can still swivel like that, but they can't somersault or they can't tumble over sideways. So that's locked position in Y and locked rotation in X and Z. We're going to do exactly the same for the big enemy. Lock their position in Y, can't go up and down, freeze rotation in X and Z, can't tumble over. And then we should see that they kind of move a bit like the player-ish. They don't tumble over anyway. They can still get nudged by the lozenges, which is kind of cool. So that still has an effect. There's still a physicsy feel to it. But they are not falling over. And in fact, they don't even face us. They probably should face the direction they're going, but I don't think we'll do that today. So that's kind of cool. If you want to... oh, sorry, I'm just going to check that this is recording. Every now and then I get paranoid that that's not. What other differences could our big enemy have? They're slow, they're big, they should be tough as well. And so we're going to give them a health value, and it's going to be a different health value to the rest of the enemies, and that's fine. We could do that right now. We could just, you know how to do this already, because we have already added a public float for speed. We could just add a public float for health, but we're not going to, because I want to take advantage of the way Unity does things and sort of illustrate what that is. What's different about Unity and kind of the way Unity likes you to do things is to do with these components on a game object. So our enemy behavior is one component. If we're going to give them health, it's not unlikely that we'll also want to give the enemy, we'll also want to give the player health. And we might want exploding barrels, and they'll have health. And we might want, I don't know, innocent bystanders, and they have health. And if we put a tree in the game, maybe the tree has health and can be destroyed. Loads of things might have health. And if we just add the concept of health to an enemy, and then we add the concept of like, okay, if your health goes below 0, we want you to die to an enemy, that's fine, but we'll have to then write that same code again for the player, we'll have to write the same code again for trees, we'll have to write the same code again for, I don't know, explosive barrels. All these things that aren't really very similar to each other. They just have health in common. They just all have a health system. But other than that, they're not, they don't have anything else in common really. And we would have to write that code for each of them over and over again, which is, you don't want to avoid writing code over and over again, because it's when you come to change it, you have to change it in loads of places. It's a big pain. So let's make it a separate thing. Let's do it on the big enemy first, since there's only one of those. Go to add component, new script, and I'm going to write the words health system. We're going to create a new behavior. So the fact that we added a behavior here doesn't prevent us from adding other behaviors. We can stack them up as much as we like. And if I open that up, this one will be a mono behavior. You know, it's a component. It's something that determines how a game object behaves. And we will give it a public float, not flot, health. I won't give it a value because we're going to set that in the inspector because it's a public variable. What else shall we do right now? Let's just go back to Unity and just show that worked, and that we can now set health. So let's give this guy 4 health. And then what does this behavior do? What does a health system need to do? What I want to be able to do is, right now, when a bullet hits something in bullet behavior, we have this on collision enter thing. This is when a bullet hits something, it just checks if it's an enemy. If it is, destroys them. So this is the line of code we're ultimately going to change. And what I want to write here, instead of destroy their game object, is, you don't have to write this yet, but I want to write a line that's a bit like, basically them.take damage 1. So I want to run a function that says you take some damage, and I give it this argument, this detail, that the amount of damage you should take is 1. I can't do that yet because that function doesn't exist. No one's written that function. So we got to write that function. So, start and update of functions, we've been working within those. Now we're going to write our own one for the first time. And we're going to write public void take damage. And open brackets, float, damage amount. You can call this variable whatever you like. We're declaring a variable here. And then we open some curly braces. So I raced through that a bit, so I'm going to go through and explain what we just did. Public is, in this case, we're not making it public so we can set it in the inspector. We're going to write it purely in code, but it needs to be public for anyone else to see it. If we didn't make this public, then bullet behavior would not be able to run take damage. We wouldn't be able to call take damage. We wouldn't be able to tell this health system that it's taken any damage because that function is not public. So we have to make it public. The word void, you will have seen this before start, you will have seen this before update. What that means is the function doesn't return anything. So when someone comes to you and says, you're taking 3 damage, you just take 3 damage. You shut the hell up about it. They're not going to need any information back from you. It's possible one day we might change our mind about that. We might say, oh, every time we tell someone to take some damage, we want them to report back how much health they have left. I don't know why you'd want that, but maybe you would. If that was the case, we wouldn't write void here, we'd write float, because we're going to give back a number. But when you write void, it means the function doesn't give back anything. We're not going to tell anybody anything after we take damage. We're just going to take some damage and deal with it ourselves. Not great mental health advice, but that's what we're doing here. And so that's why start and update both have void on them as well. It's because when the thing starts, it just does some stuff. It doesn't tell anybody about what it did. And when the thing runs an update every frame, it doesn't need to tell anybody what the result of that update was. It just runs the update. So void just means a function that doesn't do anything else. And then take damage was our name for this function. We could have called it anything. And then we opened brackets, and then within these brackets, we declared a variable and didn't set it. So we said, we want a variable of type float, and we're going to call it damage amount. But it's not us setting what the value of that is. What we're really saying here is someone is going to give us a float variable, and for our purposes, we'll call it damage amount. They're not going to call it anything. They're just going to give us a number. But when they give us a number, store it as damage amount. So it's declaring a variable, and we don't need to set the value because the value will be whatever is in these brackets when someone calls this function. And then all the actual function is going to do is just say health reduced by damage amount. Pretty simple. And then after we've done that, we should check, is our health now less than or equal to 0? If so, then we should destroy our game object. So that is the same line that we had in the bullet code before. The bullet code was just forcibly destroying anything it hit. Now the bullet code is going to very politely say, excuse me, sir, I wouldn't dare to destroy you, but I have to inform you you've taken 1 damage. And then very politely the health system can say, 1 damage. Let me reduce my health by that. And then, how does my health feel now? Oh, it's 0. I'm dead. Destroy my game object. That was a needlessly theatrical interpretation of what's happening here. But that's why we're doing this. First we reduce the damage, and then the health system is going to be the one that checks if we've run out of health, and if so, destroy our game object. This is that difference that we just made. Rather than this outside object comes in and forcibly destroys us, instead it tells us something, and then we decide how to deal with that information. That's a good direction for your programming to go. I don't know if I phrased that right. That's a good principle in general. You want as much as possible for your code to be in these nice little self-contained parcels that they don't need to know much about how the other parcels work. They just deal with their own things. And when you define your own function like this, a public function, or public method, it's sometimes called, you are defining a way in which the health system can be affected by outside factors. You're saying, look, you don't get to destroy me, you don't get to do mess with my inner workings, you don't get to do anything like that, but you are allowed to tell me how much damage I just took. That's the way you're allowed to talk to me. And I know how to deal with that. I can handle the damage. With another system, we might have different ideas of what it can, how you can talk to it. But when you declare a public method, you're kind of saying, here's how things can talk to the health system. And it's good to do things that way. If we did, I won't get to counterexamples yet. Hopefully that's clear enough for now. We have a health system, it can take damage, and it will destroy the game object when we run out of health. And so the last thing to do is go back to bullet behavior, and now that line that we almost wrote, we can't quite write it yet because we still need to, in fact, let me show you. I can't just write, their game object dot take damage. Take damage is on the health system component. So we need a reference to the health system component. So we will actually declare a variable type health system. Every script we write, we're creating a new type of thing. It's a variable type, just like vector is, just like game object is. We've created our own thing. So we can create a variable like that. And I'm just going to call it their health system. A long name, but it's clear. And where are we going to get that from? We're going to go to their game object, dot get component, and the type we're going to enter in pointy brackets is health system. And then there's some regular brackets on the end there. So now we have a reference to their health system. Now we can write their health system dot take damage brackets 1. And you can easily imagine that instead of that 1 there, we could have a public float damage up here. And then, in fact, let's just do this. It's going to be as easy to write as it is to say. So let's just do it. We declare up top a public variable called float. That's because it's public, we'll get to set that in the inspector later. And instead of taking 1 damage, we're going to take damage. What I mean is, the bullet will deal as much damage as we tell it to in the bullet prefab. So, just to recap, this is a bit of code that used to just destroy the other game object. Now it checks to see if they have a health system, and if it does, it deals some damage to it, however much damage we say a bullet does. The health system, meanwhile, when it receives that damage amount, it subtracts it from our health, then it checks if our health is 0, and then it destroys us. By us, I mean whatever has this health system component on it, in this case it's the enemy. It's the big cube enemy. So back in Unity, we do need to do one little thing, which is that bullet prefab. We are going to want to scroll down to bullet behavior, and we created this damage field, but we didn't set it to anything yet, so let's just set that to 1. So it is only going to do 1 damage, but later we might want to change that as we balance the game. So, should now find, I can shoot this thing, after I shot it about 4 times, it dies. We did get an error there. Are we getting lots of errors? We are. Why are we getting lots of errors? I'll double click it and find out. Oh, excuse me. Yes, sorry. We kind of we should do one more thing here, which is we were just saying, get their health system and do some damage to it. We don't know for sure that the thing we had has a health system. So we ought to really say, if their health system not equal to null, then we'll deal some damage. So this, it probably won't be a problem anyway, because we're going to add a health system to every enemy, I think. I don't think there'll be a type of enemy that literally doesn't even have health. But Unity is quite right to throw an error on this. It's good practice to check that this thing is not null before we start doing things with it. It's not sort of automatically inherently true that anything as an enemy must necessarily have a health system. In our case, it probably will always be true, but if it's not necessarily true, it's good to check that it does exist before you do something to it. And so the whole reason we did that was so that the big enemy could have more health than the small enemies. What was the big enemy's health? It's not letting me scroll for some reason. It's loading. I have a terrible time finding... Okay, I'm looking at the bullet, that's my problem. I did click on big enemy, but I guess it didn't... it was busy doing something else at the time. Big enemy's health is 4. Let's go to little enemy. We don't want to edit the individual instance, remember? So when we do this, we go to prefab open up here. We could also, instead of having the console up here, I should probably just double click the enemy prefab down here. But you can also, from any instance, you can click on prefab open up here. And then we get to the real, or not the real enemy, but like the source enemy, the blueprint for enemies. And we want to give them a health system. Add component, health system. And pops up right away. There's a health field, it's 0, that would be weird. Let's give them 1 health. And then let's just test that. So now we should find these guys can die again. I don't think I explicitly showed this before, but they wouldn't have died when I attacked them before. And yeah, the big guy takes more health, but takes more damage than them. So now we have a way of differentiating enemies. We can change their speed, we can change their health. And so the whole reason we did it this way, I mean, it's cool that we can put it on both those types of enemies, but actually they both have an enemy behavior, so that that would have worked even if we'd just added health to enemy behavior. But the nice thing about the way we've done it is we can now just add health to the player as well. Just go to the player, add component, health system. How much health should the player have? I'm going to say 10. And how is their health ever going to be reduced? So our enemies can't fire yet. I think they probably will at some point, but we haven't allowed them to do that yet. But they do move towards us, so when they touch us, I think we could make them reduce our health. So imagine, if you will, a piece of code that when the game object it's attached to touches something, it deals some damage. Hey, look, that's exactly what I'm looking at right now. Where is this? This is on bullet behavior. This is how bullets work. Bullets are just very fast traveling enemies. So I am going to copy and paste this entire thing. We are going to edit it. I've said before, you shouldn't really be copying and pasting big chunks of code if you're just going to leave them as is, because if that code is the same in both places, you should probably find a way to only write it once and have both those places refer to it. I am copying and pasting here, but we're going to change it, so that's fine. And on enemy behavior, we're going to just below update, make a few new lines, paste all this. Yeah, there'll be some issues here. But the first line we do want, so we do want to get a reference to their game object. What did we collide with? When this was lived on a bullet, we were checking, hey, do they have an enemy behavior component? Well, we don't want that now because we are an enemy. We're checking for a player behavior component now. If their player behavior is not null, then by all means get a reference to their health system. And if that wasn't null either, then they should take some damage. It shouldn't be damage, it should be 1 damage. And so again, we could set our own damage variable, and in this case I don't think I will, because this bumping into the player and dealing damage that way is a little bit weird. We might not stick with this, but it's a good way of just giving the player a health system. And we're going to remove this line at the end. That was to destroy bullets when they hit something. We don't want the enemy to die when they touch you, because that would make it too easy. So yeah, with a few modifications, that bullet code works fine for us. It's going to find the game object we hit, check if it has a player behavior. If it does, look for its health system. Assuming you found it, then tell the health system it took some damage. And our player has 10 health. So I'm going to keep the player selected in the scene view here so that this inspected and the... oh, excuse me, I need to wait a sec. No, I don't. I selected them in the inspector so we can see their details down the right-hand side, and the one I'm interested in is health, the health system, because we don't have an in-game readout of health yet. We should have at some point. And what I want to see is, I want to watch that 10 value when we touch something. It goes down. And so I suspect, yep, that killed us. When we die, obviously there's no way to respawn or anything, so we've got to start the whole game again. So I can shoot enemies, and they can hurt me. I'm just going to very rapidly click on the player. And, oh, that's interesting, actually. He had me cornered there, and my health wasn't going down any further, because I think this is... all that stuff we wrote is on collision enter. That's on the moment we hit them. And so if they stay in contact with you, they're probably not triggering that again and again. They're probably just doing it once. And like I say, this collision-based damage thing is probably not going to stick, so we're not going to worry too much about it being a little bit janky and weird. It's just a way of showing the player can have health, and when they run out of health, they die, and we can no longer play the game. We might notice we're also getting an error here. I expected this, because this is our nice new player reference. Once the player is destroyed, we didn't just make him fall over and lie on the ground. We annihilated him from existence. That means our reference is now null and void. It doesn't work. So I think we should fix that. It's actually quite an easy fix, because the actually I'll show you again. If we double click this error, it'll take us to the offending line of code. It's this thing in enemy behavior that seeks to the player. That's the time we're referencing the player. And we don't need to get rid of that. All we need to do is just check that the player exists first. So we just check if references dot the player not equal to null, then open some curly brackets and only do this part then. And in fact, now that we've written this, the only time we need to access our rigid body is if we are going to seek to the player, so we can put the rigid body thing in there too. So all of that code now is inside an if statement that just checks this references dot the player thing that we're going to use down here. Make sure that's real before we start to talk to it, because otherwise we'll get an error. So that should fix that. Not that there's much to do in the game after we're dead, but it's good not to avoid those errors as they come up. And yeah, it's good to avoid them because if you don't, you can get in a muddle yourself. Like, that error is happening because Unity is saying, oh, you've made some assumptions here that aren't justified. And in our case, it doesn't really matter because the player's dead and the game's over. But later we might modify this code and we might just see the fact that we referred to the player here and assume, oh, this means the player must exist. We must have checked that somewhere. And we haven't, so we should. So yeah, that's the end of this lesson in terms of the main thing we wanted to do. We've got a health system, we can make different enemies. I'm trying to focus on things that once you've learned them, you can go off and do your own stuff. So now that you know how to make enemies with varying health and speed, you can make as many of those as you like. I assume that we could make this big enemy into a prefab just by dragging it over here. And once we've done that, we could drag others in there and have multiples. Remember we locked this guy in the Y dimension? I wonder what happens if we put him in the game, but off the ground. So he's still going to chase me, but he can't ever find me. What happens if he's like a bit off the ground, like too hard off the ground to hit me, but enough to collide with the other guy? Do they ever get... Oh yeah, they do. They can bump into each other. It's made him spin, actually. Because he can spin on the y-axis. Because, okay, so the top one is spinning and the bottom one isn't, because the bottom one has friction. The bottom one is on the ground, so it has friction against the ground. And the top one doesn't, so every time it gets a bit of impulse, it spins for a while. It would be kind of cool... Oh yeah, I know what I wanted to try. I wanted to try... Actually, I'm just going to move this guy in the hierarchy because he's... Let's keep the similar things together. I don't know why. Why did the enemy move? what I was interested in trying is in our health system, now that we have a thing that's on both players and enemies, I thought it might be interesting to say, what if our, how could we do this? For every time we take damage, we change our transform.local scale, that is our size. We could multiply it by, so that's asterisk equals multiplied by 0.5 f. So that just says that we will halve our scale every time we take damage. Doesn't matter how much damage we take, we'll just halve it every time. And that's our current scale, so it's not like 2 shots will make us disappear. It's every time we'll halve whatever current scale we have left. I explained this in the reference doc, but yeah, basically every time you write a decimal number, you're going to have to put an F on the end of it, annoyingly. We could have done divided by 2 there, of course. That might have made more sense. So let's see what it looks like if a big thing... Oh, every time... Oh, what happened there? Oh, I know what happened there. I can't shoot him anymore because he's no longer on the ground. If I pause the game and then go to scene view, he has... we shrunk his scale, and his center point is up here somewhere. And in Unity, when you resize something, it resizes around that, whatever it's actually called its pivot point, not its center. By default, it is the same thing as its center, but that's something we'll actually fix in a future episode because it's actually not good for this very reason. It's not good to have your center be your pivot to be in the middle, because if you shrink, then you shrink off the ground. The way I've done it in Tactical Breach Wizards is that every character's pivot point, their true location, is actually at the bottom of their feet. It's in the middle of them, but the feet. Does that make any sense? What I mean is it's the center of the square they're standing on, and that works out really well. It simplifies a lot of things if you just can always say your location is your ground location. It's the spot on the ground you're standing on, and it's not in the middle of your chest, because that causes complications like that. Anyway, I think that's all I wanted to mess around with here. I think you can see... actually, no, let us just fix that one thing. Let's see if... Oh, excuse me, I just did a bad thing there. There's big enemies. Now that we have 2 of them and there's a prefab, I should open the prefab and I should edit that, not any of the individual instances. Let's not freeze position in Y, and that should mean they fall down now. And so then we can test our shrinking code a bit better. Yeah, so they can still follow us, and I can still shoot them. I think they fall quite slowly. And, oh, I got smaller too. I'm off the ground now, I think. Yeah, well, that doesn't matter in my case. There is a game about this, isn't there? I can't remember what it's called now, but it's like, it's a deathmatch game where as you get more kills, you get bigger. And I think as you get shot, like in the head, your head shrinks when you next spawn, and so it gets harder and harder to shoot you in the head. It does have a little bit of a nice self-balancing kind of thing, where like the more you've hurt something, the harder it is to hit, and so that'll naturally make fights a bit closer. Doesn't really factor into our game yet because it's absurdly simple. But yeah, that is it for this time.